Hey guys, quick little lesson about what ligands are. Ligands are molecules or ions that have a lone pair of electrons. It needs that lone pair of electrons to attach itself to an ion with a high positive charge density. Take a look at this list of great ligands. H2O, that oxygen, has 2 lone pairs of electrons. NH3, a nitrogen, has 1 lone pair. A Cn- ion has a lone pair on the C and on the N. This OH- ion, or hydroxide anion, has 3 lone pairs. This is the oxalate anion. It's got a -2 charge and some oxygens. It almost certainly has some lone pairs. And EDTA is a very common ligand. That's why I've included it here, but there's no way in hell I'm drawing it for you because it's too big. In fact, it's so big that it wraps around things and bites onto it in like 6 different places. These are ligands because they have lone pairs of electrons on them. And what are lone pairs attracted to? Plus charges. So take a look at this list of things with a high positive charge density. Al atoms, or aluminum atoms, with a 3+ charge. That's 3 extra positive charges in that atom's volume. Very high positive charge density. Notice all of these have charges of 2 or more positive, and they're all just single metal ions, because if you get any bigger than a metal ion, generally the charge density is going to be too low. After all, density is lower the bigger the volume is. Let me show you what ligands do though. Al3+ is a classic example. Let's put an Al3+ in the center of my paper. And then I have waters. Let's say we have a water here, lone pair, H and H. What do the lone pairs on the oxygen say to themselves? They say, oh yeah, I love me some positive charge. And they'll attach to the aluminum. It won't be a bond. It's really more of an ion dipole attraction. But what happens is you get 6 of these waters surrounding the aluminum. And for aluminum it is 6 waters, although depending on the metal ion and the ligand, that number can vary. H, that's 5. Oh, if you're into Vesper, these arrange themselves octahedrally. But each of these makes a bond. Again, not a covalent bond, but there is an attraction between the two. The last thing, or the things I want to point out here, are that usually we write this as Al3+, but when it's surrounded by waters like this, we show that it's surrounded by 3 waters by writing H2O6, the same way you would write aluminum nitrate or aluminum iodate or something. Put it in square brackets to show that it's a complex, or a positive charge center with ligands, and we put the remaining or resulting charge here. Here the charge hasn't changed because waters don't have charge. So this is the chemical formula for this, which is Al3+ and 6 water ligands. There's a special way to name these, but I'm not going to get into that right now. The last thing that I want to point out is that the bond or attraction that's made between the ion and the dipole is actually a Lewis acid-Lewis base reaction. A Lewis acid is something that accepts an electron pair. That's this guy. This guy is my Lewis acid. These guys are donating the electron pairs. They are my Lewis bases. And each of these attaching is a separate Lewis acid base reaction. Just another way to think about it. What can you do? That's ligands. So watch out for high positive charge density metal ions. Watch out for molecules and anions with lone pairs. And they may attach to each other and make sweet love into the night. Best of luck to you.